All right, guys. So the last thing that we're going to learn for the year will be on exponential functions. And so we've learned about first linear functions, which are just lines. We've learned about quadratic functions, which are parabolas. And now we're going to learn about exponential functions. So as an example, I'm going to use the coronavirus cases that we have in the US, and we're going to talk about why it's such a big deal. If you notice, we have a little chart here that tells us from February to late March. And if you notice, from February to early March, there wasn't that many cases in the US. It was still fine. But then all of a sudden, around the time the school had to close, if you notice, they start going up really fast. We call that an exponential growth, and that's the reason why we have a line like this. So it starts off really slow, but then there comes a point where it starts growing very fast, and that's an exponential function. So an exponential function is going to be written as a, and then we're going to do 1 plus or minus b to the power of t. And so our a is going to be our initial value. So the value that we start off with. Our b is going to be our percentage growth or decay, depending on the answer or depending on the problem. And t is usually time in years, months, minutes, hours, any sort of time at all. And so let's go ahead and look at this very first one, where it says, radioactive material loses its mass over a period of years because some of its nuclear material is released as radiation. The mass of a certain sample changes according to the equation y equals 500, and then inside parentheses 0.841 to the power of t. So it tells us that we want to determine the meaning of the a and b values in the terms of the problem situation. So we can label our a and our b. So our a is our initial value of 500, which means we started off with 500 units of radioactive material. So that's where we start off. We can also say that when we graph, this is our y-intercept, because that's what we start off with. Now, 0.841, since we are releasing, that means that we are decreasing. Therefore, 1 minus our b has to equal 0.841. So 1 minus 0.841 would be 15.9. So, and if let me just go ahead and write this, it would actually be 0.159. If we multiply this by 100, now we have a percentage which is 15.9%, which means that we are decreasing at a rate of 15.9%.